Hello, welcome to our presentation regarding Secure Federated Learning System. Our sponsor is Dr. Nguyen. Our focus is creating a design that secures federated machine learning and its operations.
Our design utilizes a federated network. A federated network is a distributed machine learning system where multiple devices, in our case Raspberry Pis, collaboratively train a shared global model without ever sharing their data. They do this by sending their model updates over a network to the main server. The main server aggregates all of these model updates and uses an averaging mechanism to build its own truth model. Now there are two threat vectors that we need to be aware of in this network. An actor could run a man-in-the-middle attack on the transmission of these model updates in order to intercept them. An actor could also compromise one of our edge nodes or poison its data. In order to protect against a man-in-the-middle attack, we are using an integrity validator to make sure that the model update remains the same before and after transmission. We are also using Kyber key encapsulation mechanism. This is an encryption which is a post-quantum algorithm standardized by NIST in order to secure our model update while it is in transit. In order to prevent against a poison node, we have digital signatures to authorize our clients, and we also have anomaly detection that will detect if one of the nodes is sending anomalous data. We also have all of this wrapped up in a security incident alert system, which will notify the administrator through a graphical user interface if there are any issues along the way. This is how our Kyber key encapsulation mechanism operates. The server generates a private key and a shared key. It then sends its public key to the client. The client uses this public key to make a shared secret and ciphertext. That ciphertext is then sent back to the server, which decrypts it using its secret key, which was never shared. That means that both the client and the server now have their shared secret. So even if the server's public key gets intercepted, the shared secret can't be acquired. So the dataset that we are using is the HAR dataset, which is human action recognition. The AI is trained to recognize different human activities like walking, sitting, standing, etc. This is all based on data from motion sensors. These patterns are used to build a truth model that helps the AI understand and classify human movements.
We determine anomalous or malicious data based off the L2 norm of the weights coming from each of the client updates. The L2 norm is otherwise known as the Euclidean distance, and we know that it's malicious data based off of our requirement set or our threshold set to 2 standard deviations greater than the L2 norm. In the bottom right, we have the formula that shows the Euclidean distance. It's a simplified version of the formula, and it's what we employ. The software design can be broken apart in 2 primary applications, the client and server application. The server application runs on the server computer, while all the clients run their respective client applications in the background of their own devices. The server application is concurrently programmed to support 1 client session per thread. And it joins all these threads before conducting its aggregation algorithm on all the client models. Furthermore, the server facilitates the Kyber post-quantum cryptographic exchange as well as the encryption and decryption for the machine learning models. The connection handling facilitates the use of the RSA digital signatures for authentication. The client code will train a fraction of the dataset locally and report the update to the server. And you will see, after a certain amount of epochs, convergence between these client models. As for incorporating this onto the physical network, the design requires that the Raspberry Pi devices and server have their own devices RSA keys registered onto the network. The administrator will open the application and bind their respective IP address to the session and initiate the federated learning by pressing the start button, and that starts the process between the client and all the clients and the server. And as seen in the graphical user interface, the administrator can view an interactive graph that shows the convergence, as well as the overall training accuracy and training loss. And finally, there's a log at the bottom of the screen that shows all server updates regarding encryption, decryption, and an overall anomaly detection.